So we're going to do some equation solving today. I'm always an equation solving fan. First things first, let's just do this quick warm up because we're going to need to expand some logs today. So remember, if you have terms being multiplied, you can expand them out in logarithms added together. And any exponents you have, like that squared on your x, should get multiplied in front of your logarithm. So how do I solve an exponential equation if I can't just guess and check whole numbers? Well, let's do the log that matches the base on both sides. Exponential functions and logarithms are inverses, kind of like you square root something that's squared. We're going to do log base 9, since this is a base 9 exponential function, which those will undo each other. You'll just get x on the left equals log base 9 of 35. And then that's not a whole number, so we're going to use our change of base formula from yesterday and do log of 35 divided by log of 9 in a calculator, and you should get approximately 1.6181. If you have something else involved with your exponential function, you want to get your exponential part by itself first before you do a logarithm. So I'm going to divide both sides by 100, which is just going to give me my exponential part equals 2. Now use the logarithm that matches the base of your exponential, so do log base 1.02, even though it's ugly, of both sides of your equation. And by doing that, on the left-hand side, you just get your exponent back of x over 4. I'm just going to leave the right-hand side as it is for a minute. I'm not solved for x yet. I need to multiply both sides of my equation by 4. Which will make it x equals 4 times that logarithm. Now let's actually approximate it. So if you use your change of base formula, you'd have 4 times log of 2 divided by log of 1.02. Punch it in a calculator. People tend to screw these up in calculators, so just be super careful with all your parentheses. You should get approximately 140. This one involves a lot of e's, which look kind of scary. The main thing is there are two exponential functions. We want to combine them first, so add your exponents together and make that e to the negative 2x plus 1 power. Then it's a single exponential, which we can undo by taking natural log of both sides, since natural log is log base e. Those are going to undo each other on the left. You'll get your exponent of negative 2x plus 1 back. And then I'm just going to go ahead and, in my calculator, do natural log of 3e. When it pops up like a power on an e, if you're using a regular calculator, type 1. I jotted down my decimals, but I'm using my answer button as I go through here. I'm not rounding it off along the way. So subtract 1, take your answer that you got, divide it by negative 2, and you should end up with approximately negative 0.5493. Okay, this one's gonna get messy, but we can do it. You can't really do log base 5 or log base 2 because both sides of your equation have different exponential function bases. So we're just gonna throw it all out the window and do natural log of both sides. When you do that, use your property that allows you to bring your exponent out in front and multiply by it. So I'll have x plus 2 times natural log of 5 on the left-hand side, and 2x minus 1 times natural log of 2 on the right. Then it's going to get a little messy algebra. So I want to actually multiply my natural log of 5 and my natural log of 2 times both terms there. So a little distributive property, written perhaps kind of backwards, but you have x times natural log of 5 plus 2 times natural log of 5 equals 2x times natural log of 2 minus 1 times natural log of 2, which is just natural log of 2. Okay, we're solving for x. Our variable right now is on both sides of our equation. We want to get everything that involves our variable on one side and our constants that don't on the other. So some rearranging. Let's go ahead and add natural log of 2 to both sides and subtract x natural log of 5. So if I do that, on the left, I'm going to have 2 natural log of 5 plus natural log of 2. And on the right, 2x natural log of 2 minus natural log x natural log 5. Those aren't like terms because the logs are different values inside, so don't go combining them or anything. There's still x in 2 terms over there, so I'm going to factor that x out, which leaves me with x times 2 natural log 2 minus natural log 5. Left-hand side, still the same. Going to do a little copy and paste here. To get x by itself, since you have x being multiplied by that whole entire quantity, I need to divide both sides of my equation by that whole messy quantity. So if you do that, it's going to look like, paste again, all over 2 natural log 2 minus natural log 5. When you type this in a calculator, either do the top, do the bottom, just write them down with lots of decimal places and divide them, or be sure you put all those parentheses that I have in mind, where you have the top in parentheses and the logs have the parentheses closed around them, and then the bottom in its own set of parentheses. The parentheses are key! Should get negative 17, approximately.